So today we'll be comparing materials and objects according to properties. Alright. So you guys are going to be given sand, Play-Doh, paper mache, soda, and Mentos. And you are going to compare their materials and their object and compare the materials of each object according to the properties such as size, shape, color, texture, and hardness. And I want you guys to do this with mostly accurate, about 75%. There's room for a few mistakes, but that's it. So for the second part of the worksheet, I want you guys to compare liquid volumes and masses of objects using grams and kilograms, again with 75% accuracy. Room for a little mistake, but I want you guys to be mostly accurate. Now, before we start our lesson for today, I want you guys to call upon your prior learning of distance. Now, I want you to ask yourself, how far away is our school according to kilometers? How far away is our school from the Challenger Learning Center, Tallahassee? Now, our school is 99.6 miles away. How many miles go into a kilometer? Go ahead.
1.60934 kilometers.
Correct. Alright. Can anyone tell me how you get miles into kilometers?
Do you times them together?
You do. Alright. So if our school is 99.6 miles away and 1 mile is 1.60934, what would we get if we times them together?
160.2907.
Correct. Our school is 160.2907 kilometers away from the Challenger Learning Center of Tallahassee. Now, what is the point of properties and distance? The point of learning about them is so we can classify objects into groups, and we can also tell how far away something is. For example, we classify candy by groups. We classify them by, let's say, M&Ms and Skittles. They're hard candies. But you have, let's say, someone give me a candy that's not M&Ms or Skittles.
Gummy worms.
Gummy worms, okay. So you've got gummy worms and gummy bears, and they are in the same classification because they're gummies, right? Alright. So, what are properties? Can anyone tell me?
Are properties like physical things?
They are. A more in-depth description of them is a physical property is any property that is measurable, whose value describes a state of a physical system, like color, shape, and texture. And the main properties we're focusing on today is color, shape, size, texture, and hardness. Now, what are some examples of the paper physical properties?
Paper is smooth.
Yep.
It's thin.
Mm-hmm.
It's multicolored.
Yep. Alright. Now, I'm going to take these two candies. I'm going to take a powdered candy and a squeezable candy, and I'm going to pass it around the room, and I want you guys to tell the difference, okay? Like, tell the properties. Open these.
Miss Fitzhugh, while you're opening candy, I have a question.
Go ahead.
Is everything a property? Can everything be like classified as a property?
Yes, you have two types of property. You have physical property and chemical property. Chemical properties are like the boiling point, the melting point, and all that stuff. You'll learn that in high school. Alright. what are your assumptions about this kind of candy?
It's gonna be multicolored.
Okay. Do you think it's going to be hard or soft?
Soft.
Alright.
I think it's gonna be runny and liquidy.
Alrighty.
And the one you're holding, I feel like it's gonna be like dry and powdery. And probably more sour, because I feel like powdered stuff is usually more sour than like liquid stuff.
Okay. Okay, I need one of my students to open this because I cannot. Alright, thank you.
You're welcome.
Alright. Alright. Now I'm going to pass around the candy. This is the squeezable one and this is the powder one. And I want you to tell me, now that you've seen it, how do your assumptions differ from what the different properties are?
One is a little bit, the powdered one is a little bit more coarser than like salt, probably like more like sugar. And the other one is really smooth and liquidy and like you don't see any like particles. One's white and one's clear.
And what do you see?
I see the same thing. I thought both candies would be like more brightly colored.
Mm-hmm.
I was not expecting the squeezable candy to be clear because the packaging was so colorful. It's very sticky, and the powdered candy is not sticky. It's very dry.
Thank you. Alright. Now, one of y'all said that the liquid candy was going to be smooth and runny. But that was you? Alright. Well, as you can see, it is very sticky. And it is not runny at all. It is congealed and sticky. While the smooth one is, honestly, it has the texture of sand. Alright? Alright. Now, who can give me some other examples of things being classified by their properties?
Like a laptop,
Okay?
because a laptop is thin and it can be different colors and it can be smooth, but also the keys make it bumpy, but like they're still smooth and like the edges are rounded. And there can also be sharp things because of like stuff like you add in like different wires and stuff. And it can be multicolored and it can change according to like what laptop's what.
Alright?
Different blocks for kids to play with. There's smooth blocks, then there's blocks like Legos that have the little bumpy connectors, and then there's also blocks that are made out of foam.
Yes. So building on that, how do you think Lincoln Logs and Legos differ?
Lincoln Logs are more like they have cutout notches to connect things together and build that way, where Lego have the little circle connectors that you can stack.
Mm-hmm. Now, can anyone tell me what the difference would be between a Coke can and a baby bottle? Like, what's the different properties between them?
Well, for one, they're different materials. Cans are usually aluminum and the bottle is made out of plastic. The Coke can is thinner of a material. It's like really thin and you can bend it, while the bottle is a thicker plastic and you can't bend it.
And a bottle has the silicone top to it, and a Coke can has the tab that you pop the drink open on, which is hard because you could actually cut yourself on it.
Very good. Now, one last question for right now. What do you think the difference is between wood and brick? Like the properties.
I think brick is harder than wood.
Mm-hmm.
I think it's also easier to break wood than it would be bricks. I think wood would catch on fire and bricks would not.
Anything to add?
I also think that brick molecules are more like compact and bigger than wood molecules. I think wood molecules are smaller, which is why it can be smooth and bricks are rough. And wood can be stained different colors and like spray painted and stuff, but brick can't.
There you go. Alright. So, where are we at in our understanding of properties? Are we at green, we're good to go? Yellow, it's okay, but still don't get it? Or red, completely lost?
I'm at green.
I'm at green too.
Alright. And did we talk about liters and grams? Okay. So for grams and kilometers are the measurement of mass. Who knows what mass is? Okay. Not to worry. We'll just recall in a previous lesson. Mass is weight. Like my mass would be, I don't know, so how much I weigh. Doesn't matter. Okay. But, so mass and grams are how you measure weight. Liters are how you measure the liquid volume. Okay? Are we green, red, or yellow on those?
Green.
I'm green.
Okay? Alright. Now, I'm going to pass around these two objects at different ends of the room. A rock and a keychain bear. Now I want you guys to tell me what the properties of each are.
Well, my bear is soft and it's almost like furry. It's different colors. It's brown and dark brown, black, white, yellow, and red. The clothes on the bear are a lot smoother than like the actual bear's body, because the bear's body is more like fluffy and like fuzzy. And it's soft, and there's a hard chain on the bear. The eyes and the nose are hard.
Alright, and your tooth? Or a rock?
It's small. It's long, almost triangular, but not quite. It's beige colored. It's very smooth, and it has a point to it, but it's not a sharp point. It's kind of blunt, and it has a silver keychain hooked to it.
Alright, so based on your property assumptions, how do those two things differ in their properties?
Mine is very hard, where hers is very soft.
Mm-hmm.
Mine's round and mine's like rounded off, while hers is pointed.
Mm-hmm.
Hers is multicolored, and mine's pretty much one color.
Alright. Now, how do you think those objects would differ in mass? Which do you think is heavier?
I would say that the rock would probably be heavier because it's more dense, while the bear is more light.
And I think the opposite. I think that her bear would weigh more just because it's bigger.
Alright. Now, today's assignment, I want you guys to break into groups of no more than 3, and you're going to go to each station to fill out your worksheet you should have gotten at the beginning of class. You go to the Play-Doh station, the sand station, the paper mache station, the Coke station, and the Mentos station. And you'll fill out the grams, kilometers, size, shape, texture, hardness, and color of each of the stations. Alright, this is what your worksheet should have looked like, and you should have gotten it before class. Did anyone not get it?
I didn't. I got it, but I have a question about it.
Go ahead with your question.
The Coke and the Mentos, if those were, I know they're like different objects on the thing and we're not going to put them together, but if they were put together, would that change the density of the Coke because the Mentos dissolved in it?
It would, but it would all, because of a chain reaction, a chemical reaction, the Mentos would cause the Coke to shoot up like a volcano. So since we're not going to do that because it's messy, you're just going to measure them individually.
I also have one more question.
Okay.
For the Coke, when we measure the hardness, are we measuring the actual like liquid Coke's hardness? Or are we measuring like the bottle or the can that it comes in? Like what exactly we're
You're
doing?
measuring the bottle or the can that it comes in. You're not, for the Coke station, you're just measuring like the can mass or the can grams, and then that's how you measure the Coke. Right? If that's all the questions, you guys can go into your stations.